Algebra 2, Lesson 2-2. Solve the following absolute value equations by graphing. Okay, first we need to break it up into two. So we've got y equals the absolute value of x minus 3 plus 2, and y equals 5. Let's do y equals 5 in a different color. Y equals 5. So let's draw y equals 5. And let's see, that's 4, 6, so 5 is going to be right in the middle. Okay? And now let's draw this one here. Let's draw this one here. What do we got? Well, we've got HK, that's the vertex, and that's going to be 3, 3, 2. So let's find 3. 2, 3, and then 2 is going to be right there. Okay? Now, so we got that. Let's use this point 4 here. Let's use 6. So y equals the absolute value of 6 minus 3 plus 2. And that's going to be 6 minus 3 is 3 plus 2. So that's going to equal 5. Absolute value of 3 is 3 plus 2 is 5. So we've got 6, 5, and let's see, 6, 5. That's going to be right there. And then we'll try, well, let's just put 0 in there. We'll put 0 in there. We got 0 minus 3 plus 2. The absolute value, well, 0 minus 3 is negative 3, and the absolute value of negative 3 is 3, and 3 plus 2 is 5. So we've got 0, 5. And there we go. That is our equation. So x equals 0 or x equals 6. And we can do that in our graphing calculator as well. Let's go in our graphing calculator. First thing you always want to do is clear your calculator. Go to graphs, and we need absolute value. And we have x minus 3, x minus 3, go outside, and we got plus 2, ooh, it's still inside. Plus 2, and press enter, and there it goes. And then we'll press tab, and we'll get a new line, and we'll put the 5 in. And there it is. Okay, we need to find these two spots. Might be a little bit difficult on the calculator. Let's see, menu, and let's see, 6 for analyze graph, 4 for intersection. Let's set the screen, 0, 5, good. Menu, 6, 4. We'll set the screen, and I can show you how to do this in class. There you go. So 0, 5, and 6, 5, which is what we got here. Okay? Good deal. That's how you do it on the Inspire. What about this second one here? What about this second one here? I think first, yeah, let's do that. Let's do that. We've got y equals 2 times the absolute value of x plus 1 plus 5, and y equals 9. Again, I'm going to do that in a different color. Y equals 9. So let's graph that. See, 8, that's 10, so 9 would be in the middle of that. Maybe just a tad low. That's going to be one of those. I guess the grid ain't just working right, not a problem. So that's y equals 9. And let's graph the other one. We have -1, 5, that's going to be our vertex. -1, 5, that's going to be about right there. Okay. Now we need to pick some points. I'm going to pick, we'll do +1 over here. So we've got y equals 2 times, and that's 1 plus 1 plus 5. And so we got y equals 2 times the absolute value of 2. And the absolute value of 2 is 2. And 2 times 2 is 4 plus 5. That equals 9. So 1 is right here, and 9 is, did I pick 1? I did. And I just had to work out kind of perfectly again, didn't it? Let's see, let's go to -3. I should have picked a number on that line, but I didn't. So what do we got? We've got, let's try -3. -3 plus 1, and that gives me -2. Well, what's the absolute value of -2? That's 2. And 2 times 2 is 4, plus 5, that gives me 9 again. Well, that worked out real well. -3, 9. And let's draw our graph. And there we go. Should have put my little arrows on there as well. All right. So we have, this time we have x equals, it looks like 1, and x equals -3. And you can go in here in the calculator. We'll do the same thing again. On new document, no, we always want to clear it out so we don't have a bunch of stuff in there. And we got 2 times absolute value of x plus 1. And then we got plus 5. Oop, did not go outside the, had to go outside the fence there. Plus 5. And I didn't put an x in there, I thought I did. X plus 1, there we go. Press enter, and let's put our other line in, and that was y equals 9. Enter. Find those points. Menu, 6, 4. -3, 9. Menu, 6, 4. Over here, and there it is again. 1, 9. Which, so we got y equals 1 and y equals -3. Number 3. Remember, first we want to rewrite it as y equals -2 times the absolute value of x plus 5 plus 4. That's one equation. Our second equation is going to be y equals 2. I'll go ahead and draw the y equals 2 because it's the easiest to draw. And that's going to be right there. And, well, then we want to draw our other line. We know our vertex is going to be -5, 4. There's the -5, and there's the 4. So -5, 4 is going to be right there. Now, we notice that A is -2, so it is going to be pointing down. Okay? And let's see, let's try -8 here. Let's try -8. So we got y equals, that's -2. -2 times that absolute value of -8 plus 5 plus 4. Well, -8 plus 5 is -3. So we got y equals -2 times the absolute value of -3 and then plus 4. Well, the absolute value of -3 is 3. -2 times 3 is -6. plus 4, and that gives you negative 2. So let's find negative 2. We got, let's see, it's y equals. So we've got negative 8, and then negative 2 is going to be right there. And let's see, let's try, we'll do 0. 0 plus 5. Well, 0 plus 5 just gives you 5, and the absolute value of 5 is 5. 2 times, negative 2 times 5 is negative 10 plus 4. That gives you negative 6. So 0, negative 6 is going to be right there. Well, shoot, I didn't pick points right on the line this time. So we're going to have to find them. Well, it looks like it ought to be fairly easy. It looks like this is your point here, and I'm thinking that's negative 6, 0. That's negative 6, 0. And this point here looks to be negative 4, 0. I don't know why I put 0 there. That's 2, and that's 2. So x will equal negative 6, and x will equal negative 4. There's your 2 points. And you can try that on a graphing calculator and see. Number 4. Well, this time a is 1, but we still got negative 2, or 2 and 2 are our vertex. So 2, 2, 2, 2. All right. We got an equation at y equals 2, and I got that from here. And then our other equation will be y equals absolute value of 3/2 times x minus 2 plus 3. All right, we need to graph that. Well, I'm going to go ahead and graph the y equals 2 line. Y equals 2 line. Did you see I made a little mistake there? Has anybody noticed yet? Here I said 2, 2, and that should have been 2, 3. Okay, 2, 3. Here's your 2, and there's your 3. That's your H, and that's your K. So 2, 3 is going to be right there. Okay. Now I'm looking, I know A is positive, which means it's going to go up like this. This looks like it's going to be no solution. No solution. It will not cross. It will not cross that line. And that happens sometimes. Let's pick, let's see. Let's pick an easy point. Y equals absolute value of 3/2. And I'm going to choose 4 for x. So I got x minus 4 minus 2 plus 3. 4 minus 2 is 2, right? So we got y equals absolute value of 3/2 times 2 plus 3. Well, the 2's will cancel out, and I have the absolute value of 3 plus 3. Well, absolute value of 3 is 3, plus 3 is 6. So 6 is right there, and I got 4, 6 is right there. And then I got to try, well, let's see here. I'll just use 0. I'll put it, that was x minus 2. I'm going to put a 0 in there. 0 minus 2. All right, that's going to give me negative 2, which will give me negative 3. Well, the absolute value of negative 3 is 3, and 3 plus 3 is 6. So I got 0, 6. And here's my equation. We good? All right, let's this is more like y'all are probably used to seeing those. And we have solve each number. solve each absolute value equation algebraically. So this is the second way to do it. You have the absolute value of 2x equals 3. So we're going to have case 1. Case 1. And we have 2x equals 3. And then we're going to have case 2. And we're going to have, well, that's 2x. 2x equals negative 3. Well, why do we have two cases? The definition of absolute value is the distance of some number and 0. Okay? So, if you'll notice on the number line, you have a positive direction and a negative direction. Okay? Positive direction and a negative direction. So if some number in 0, we'll say you got, what if you say something is 3 units from 0? So here's 0 right here. Well, 3 units from 0 would be 1, 2, 3, but here, that's 3 units. Okay, and you also got 3 units this direction here. That's 3 units. Now, on the number line, that's negative 3, but if you were to actually walk it, it would be 3 units. So absolute value is always positive. Okay, it is always positive. So now let's solve. We've got 2x equals 3, so x equals 3 halves. And here we've got 2x equals negative 3, so if we divide both sides by 2, we got x equals negative 3 halves. So let's see here. 3 halves would be 1 1/2, that's right there. And negative 3 halves would be negative 1 1/2. And there you go. Now let's try number 6. Case 1. We're going to have 1/3 x plus 4 equals 3. And then we're going to have case 2. We have 1/3 x plus 4 equals negative 3. So subtract 4 from both sides, and you got 1/3 x equals negative 1. Multiply both sides by 3, and you got x equals negative 3. Over here, subtract both sides by negative 4. 1/3 x equals negative 7. Multiply both sides by 3, and you got x equals negative 21. So negative, let's see, 22, that would be negative 21 would be right there. And negative 3 would be right there. And there you go. Number 7. Number 7. Well, let's try this. Case 1. Case 1. 3 times the absolute value of 2x minus 3 plus 2 equals 3. And 3 times the absolute value of 2x minus 3 plus 2 equals negative 3. So let's subtract 2 from both sides, and you got equals 1. You got 3 times the absolute value of 2x minus 3. Subtracting, you got 3 times 2x minus 3 equals negative 5. Okay, good, good, good. So now let's divide both sides by 3, and you have the absolute value of 2x minus 3 equals 1/3. And here you have, well, actually, what you could do, and you can save yourself, let's do this. This will save us some work, okay? Let's do this. First, we're going to subtract 2 from both sides. All right, and that gives us 3 times absolute value of 2x minus 3 equals 1. Divide both sides by 3, and you got the absolute value of 2x minus 3 equals 1/3. All right, now you've got the absolute value by itself, so we can do case 1 and case 2. 2x minus 3 equals 1/3, and 2x minus 3 equals negative 1/3. So we add 3 to both sides, and we got 2x equals, well, 1/3 plus 3 is, well, 3 is like 9/3, so that's going to be 10/3. Add 3 to both sides, so and that's going to be 1/3 plus 9/3. 3 is the same as 9/3. That's going to give you 2x equals 8/3. Divide both sides by 2, and you get x equals 5/3. Divide both sides by 2, and you get x equals, wait for it, 4/3. So we're going to have 5/3 or 4/3. Well, 5/3 is 1 and 2/3. 4/3 is 1 and 1/3. And there you go. All right, here, let's go ahead and we'll subtract 10 from both sides. You got negative 8 times the absolute value of negative x minus 6 equals negative 8. Divide both sides by negative 8, and you got negative x minus 6 equals 1. All right, now you can do, now, that brings up another point. If you get to where you have an absolute value equals a negative, then you're going to have something called no solution, okay? So, but that didn't happen in this case. So we got negative x minus 6 equals 1. Negative x minus 6 equals negative 1. Add 6 to both sides, and you got negative x equals, add 6, that gives you 7. Divide both sides by negative 1, x equals negative 7. Add 6 to both sides, you got negative x equals 5. And x equals negative 5. So negative 7 is right there. Negative 5 is right there. Good deal. Let's try number 9 here. Number 9. Isolate the absolute value expression in the following equation to determine if they can be solved. If so, find the graph of the solution. If not, write no solution. So number 9, what we got here? Well, first we're going to subtract 7 from both sides. So we got 1/4 times the absolute value of x plus 2 equals, well, subtract 7, that's negative 2. All right. Now we're going to multiply both sides by 4. 4 times 4. And we get the absolute value of x plus 2 equals negative 8, okay? The absolute value cannot be a negative number, so no solution. Number 10, let's try number 10. We subtract 3 from both sides, minus 3, and we get negative 3 times the absolute value of x minus 3 equals 3. Divide both sides by negative 3, and we get the absolute value of x minus 3 equals negative 9. Again, absolute value cannot equal 9, okay? Or cannot equal a negative number. So, no solution. Number 11. 2 times all of that. Okay. So we're gonna have 2 times the absolute value of x plus 4 plus, and then 2 times 3 gives you 6 equals 6. Subtract 6 from both sides, and you got 2 times the absolute value of x plus 4 equals 0. Okay. Well, looks like this is going to be one of those ones where you only get one solution. Divide both sides by 2, and you get the absolute value of x plus 4 equals 0. Case 1, case 2, x plus 4 equals 0. And, well, negative 0 is still 0, so let's subtract 4 from both sides, and we get x equals negative 4. So there is your only solution. Here we're going to add 3 to both sides, and we get 5 times the absolute value of 2x plus 4 equals 0. Divide both sides by 5, and you get the absolute value of 2x plus 4 equals 0. So you have 2x plus 4 equals 0. Subtract 4 from both sides, you got 2x equals negative 4. Divide both sides by 2, and you get x equals negative 2. So that's your only solution. Good? All right. Number 13. Solve the absolute value equation. Well, we got to get the absolute value by itself, so let's subtract 2 from both sides, and we have the absolute value of 3x minus 4 equals negative 1. Cannot happen, so no solution. Cannot equal, absolute value cannot equal a negative number. Let's go over here and try this one here. Let's add 2 to both sides. So we got 7 times absolute value 1/2 x plus 3 1/2. Added 2 to both sides, and that's going to give me 7. I'm going to divide both sides by 7, and I get the absolute value of 1/2 x plus 3 1/2 equals 1. So now case 1 and case 2. And let's see, I'm going to make this 7/2 equals 1, and 1/2 x plus 7/2. It appears that Windows is doing something in the background. All right, subtract 7/2 from both sides, and you got 1/2 equals, and 1, that can be, that's the same thing as 2/2, right? And 2/2 minus 7/2 gives you negative 5/2. Here we're going to, and again that's 2/2. And subtract that, and you have 1/2 x equals negative 9/2. All right, multiply both sides by 2, and you got x equals negative 5. Multiply both sides by 2, and you got x equals negative 9. So negative 9 and negative 5. Easy peasy. 15. I'm going to let you do 15 and 16, okay? You do those on your own. Should not be a problem. Let's take a look at number 17. The bottom of a river makes a V shape that can be modeled with an absolute value function. D of h equals 1/5 times h minus 240 minus 48, absolute value. Where D is the depth of the river and depth of the river bottom in feet, and h is the horizontal distance to the left-hand shore in feet. A ship risks running aground if the bottom of its keel, its lowest point under the water, reaches down to the river bottom. Suppose you are the harbor master and you want to place buoys where the river bottom is 30 feet below the surface. How far from the left-hand shore should you place the buoys? Okay. So D of H equal, well, that would be, since that's below the x-axis, that would be negative 30. Okay, because you want 30 feet below. Okay. So what do we got? We've got 1/5 times the absolute value of x minus 240 minus 48 equals negative 30. Okay. Let's add 48 to both sides, and we got 1/5 times the absolute value of h minus 240. That's going to give you equals 18. Right? We added 48 to both sides, and that's going to give you 18. Multiply both sides by 5, h 40, and 5 times 18 is 90. So case 1, h minus 240 equals 90. And in case 2, h minus 240 equals negative 90. Add 240 to both sides, so you got h equals, and I'm thinking that's 330. Add 240 to both sides, and I'm thinking h equals 150. So 150, let's see, 120, 140, 150 is right there. And 330, 320, 340, 330 is right there. So there's where you want your buoys. Cool beans? A flock of geese is approaching a photographer flying in formation. The photographer starts taking photographs when the lead goose is 300 feet horizontally from her and continues taking photographs until it is 100 feet past. The flock is flying at a steady 30 feet per second. Write and solve an equation to find the times after the photographing begins that the lead goose is at a horizontal distance of 75 feet from the photographer. Okay. Well, we've got some key information here. Their rate of travel is 30 feet per second. Okay. And they start at 300 feet from her, right? So we're going to have the absolute value of 30t minus 300, and then we got 75. Right? Okay. So 30t minus 300 equals 75, and 30t minus 300 equals negative 75. Add 300 to both sides, and you got 30t equals 375. Add 1, you got 30t equals, and that's going to be positive 225. Divide both sides by 30. Let's see, 75 divided by 30. I get 12.5. And here, t equals 225 by 30. I get 7.5. So the lead goose is at a horizontal distance of 75 feet from the photographer after 7.5 seconds, and again at 12.5 seconds. We draw 7.5, let's see, 1, 2, 3, 4. I don't do it that way there. Let's see here, 5, 10, 15 seconds, right? And so the lead goose is at a horizontal distance, and we'll say this is 100. Okay. At 7.5 here, and at 12.5, that would be about halfway in there. The lead goose is at a horizontal distance of 75 feet from the photographer in this area here, and it would look like this. That's terrible, but you get what I'm saying. All right, gets a little closer and then gets further away. All right. 19, geometry. Find the points where a circle centered at 3, 0 with a radius of 5 crosses the x-axis. So we're saying that this is the x-axis, all right? And this point here is 3, right? That point is 3. So what is this point here, and what is this point here? All right, let's see, 4, 5, 6, 7. That's going to be 8, 8, 0, and that's going to be 2, 1, 0, -1, and that's going to be -2, 0. So that's going to be the 2 points. That's real easy to figure out. Not really a hard problem, but what if we were to do it? What if we were to do it using the absolute value? You might say x minus 3 equals 5, okay? And that gives you x minus 3 equals 5, x minus 3 equals -5. Add 3 to both sides, you got x equals 8. Add 3 to both sides, you got x equals -2. That's what we found, okay? This here, we just kind of did it intuitively. And this here, we did it algebraically. Great job, folks. See you in class tomorrow. Have a wonderful evening.